Hello everyone, now we are going to solve the questions based on the combinations of the spring. For the spring mass system shown in figure 1, the frequency of vibration is n. Okay, in the figure 1, it is given that the frequency of vibration is n. What will be the frequency when one more similar spring means the spring constant is same? So you can see in the second figure that similar spring, that means the same spring constant having is added in series. So this is the series connection you can see here, and we all know in the series connection how can we calculate the stiffness, or you can say that spring constant for both the system. So we have to calculate the frequency for the second figure. That means if you consider that n2, you have to calculate n2 value. So we all know that omega is equal to under root of s by n. We know that. Here, however, the spring constant is denoted as k, so we can write it as k by n. That is omega. Okay. So here, frequency of vibration is n, so you can denote omega as n. Okay. So omega is directly proportional to under root of k. I can write it as yes or no. So this is our first equation. Yes or no? In the second figure, we can discuss about the second figure now. So in the second figure, you can see this is a series connection. Series connections means k equivalent would be k plus k, or what? This is a series connection, so we all know that in the series connections, we can calculate k equivalent like that. K equivalent is equal to 1 upon k plus 1 upon 2, because in the parallel connections, both will be added. Okay, but here this is not a parallel, this is a series connection, so we can calculate the k equivalent like that. So when you calculate this, you will get the k equivalent value will be a by 2. Okay, so this is the spring constant for the second figure. So if this is the spring constant for the second figure, so we can calculate n2 value is exactly proportional to under root of k equivalent. Okay, so it would be n2 directly proportional to under root of a by 2. Okay, so now this is our equation number second, and we have to calculate n2 value in terms of n. So we just have to put under root of k here. Under root of k is nothing but n, so that means n2 is directly proportional to n upon root 2. Okay, so that would be the final answer. That means n2 value is n by under root of 2. Okay, so this would be the answer for this question. Option B would be the correct answer. Okay, option B would be the correct answer. I am just using this directly proportional sign because I am not considering mass here. You can consider mass here, and if you consider mass in the formula, then you just have to apply here equal to sign. But the things that you get here, that will be the same. Okay, so the answer is n by root 2. That means when you added the spring in series, there will be a natural frequency which can be reduced by 1 upon under root of 2 times. Okay, so that means this is a physical characteristics you must understand. That means if you reduce the natural frequency of the system of the spring, that means you must have to add the spring in series. This is the series connection. Okay, maybe this will not be the same spring constant, this may be the different spring constant, but the thing is that they are added in series. So when you add it in series, the spring constant will get reduced. That means natural frequency will get reduced. Okay, so options B would be the correct answer. Okay, so I hope you will understand the solution of that question.